Happy day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's exercise, do not forget to like, share, subscribe, and click on notification button so that you can have more of my video. Today, we are taking the topic under vector, and that topic is on vector equation of a straight line. Now, let's consider point A here. And we consider arbitrary point P. Let's say the coordinate of point A is x1, y1, and z1. And the coordinate of this arbitrary point is x, y, and z. Now, let's have a fixed point 0. And from this particular point 0, if I'm moving to point A, my arrow will show in this direction. Let's say this particular OA is a vector because it has magnitude and this direction. The vector OA, let me call it vector A here. If I move from this fixed point to the arbitrary point here, let me call the movement and this line, the direction of this line and this line itself, let me call it a vector P. Now, I want to find an equation in terms of vector for this line AP. I will call this line APL. Now, if I want to move from A to P, this L become a vector. Now, movement from A to P, I can have alternative movements. I can move from A to O and then from O to P. Now, if I'm moving from A to O, I'm moving against this arrow. Anytime my movement is against this arrow, this vector become negative. Since I'm moving in this direction of the arrow for this vector becomes positive. So now let's start my movement from A to P. So movement A to P, which is this vector L, is equivalent to moving along AO, which is negative because I'm moving against this arrow. That is a minus vector A. Then I move from this 0 to P. Since I'm moving toward this arrow, it's going to be positive. That is a plus vector P. Now, I want to make this vector P subject to formula. This vector P actually stands for the equation of the straight line I'm looking for. So, making P subject to the formula means this minus A will go here, become positive. So, I'm going to have L plus vector A. Now, let's assume that this line is parallel to arbitrary vector. Let's call it that vector. Let's call it vector D. Now, recall that when two vectors are parallel, like this vector L for that line, parallel to this line, the relationship between them will be scalar multiplication of this second vector. That's D. So I'm going to replace vector L with this scalar multiplication of vector D. So this particular symbol, the lambda in physics, in this case is called scalar multiplication. This particular scalar multiplication is an element of a real number in the real number line. It's an element of a real number. So I will replace this vector L with this now. So now vector P now become this scalar multiplication of a vector D, this parallel vector D plus vector A. So in a nutshell, the vector A that I have here is x1, y1, z1. So I have it as lambda d plus, instead of me writing x1, y1, z1 in this row form, I can write it in the column form as x1, y1, and z1. So what I have here is called the vector equation of a straight line. Now, let's solve a problem here. Look at this question, this exercise. The question says, find the vector equation and parametric equation of a straight line passing through the points -1, 2, 3 and parallel to the vector 3, 0, -1. So, according to this question, I'm going to use this formula now. This formula. The vector P is equal to this scalar that I have here. Now, the question says parallel to the vector 3, 0, -1. That means this vector D, which is the parallel vector, I'll write it as 3 in column form at 3, 0, -1. Then plus, we are told that that straight line passed through this point. minus 1, 2 and 3. So I have it minus 1 in column form, 2 and 3. Now this particular expression, I can use this scalar to multiply everything here. So scalar times 3 will give us 3 scalar. Scalar times 0 will give us 0. Scalar times minus 1 will give us minus scalar. Then plus minus 1, 2 and 3. Now if you look at this addition, I can combine them together as this 3 times scalar multiplication with this one will give me 3 lambda minus 1. When I add this to 2, it still give me 2. When I add this one to this 3, it give me 3 minus lambda. Now the vector equation now, if I want to write this one in rectangular form, this one is standing for my x, I, this one is standing for my yj, and this one is standing for my zk. So if I want to write it in rectangular form, I will write it as 3 lambda minus 1 times I plus 2. This one will give me 2j, and then this one will give me plus 3 minus lambda then times vector k. So this one now is similar to writing xi plus yj plus zk. In this case now, my x, what I have here is already the vector equation we are looking for. So to write it in parametric form, my x stand for this, I have it as x is equal to 3 lambda minus 1, comma, my y stand for that 2. So I have y is equal to 2. Then my z stand for that what I have here, z is equal to 3 minus this scalar called lambda. Now I can make this scalar subject of formula in each case. If you look at this now, I want to make this scalar subject of formula, carry minus 1 to that side become plus 1. So I'm going to have x plus 1 is equal to 3 lambda. So therefore lambda will be x plus 1 all over 3. Then for the y, I have my y is equal to 2. Y is equal to 2. Then for this one, my z is equal to 3 minus lambda. Making lambda solve the formula, I have lambda is equal to 3 minus z. So what I have here is called parametric vector equation of a straight line. Yeah, this is the end of this class now. But before we go, please do not forget to like, share, subscribe to my YouTube channel, and also click on notification button to have more of my video. You can also help me to share this video on the various social media, such as the Facebook, the YouTube, the Twitter, the Instagram, and so on, and so even the TikTok. Please do not forget to do so. And then our next video after this one is the on a equation, the vector equation of a plane. Thank you so much for listening. Have a nice day. Bye.